Rightio, g'day students, welcome to our lesson on ordinary annuities and perpetuities. So we're going to spend a few lessons on this, and in this unit we'll be using the recurrence relationship here to model an annuity and investigate both graphically and numerically the effect of the amount invested, interest rate, and the payment on the duration of the investment or the loan. And we're going to then solve problems involving annuities, and we'll look at perpetuities today as well. So if I want to think about loans and annuities, in this case we're thinking, well, the loan, and particularly a reducing balance loan, is just a reverse of an annuity in this case. So if you were having a reducing balance home loan, for example, you would be borrowing a certain amount of money and you would be paying a regular repayment. So you're amortizing your loan, and that's those periodic repayments over certain periods. And so you'd be making these periodic payments, and the interest will be charged on your loan. Now, if you are having a look at an ordinary annuity, you're investing a certain amount, and that's going to earn interest each period, and you're going to be taking away each period a certain amount of money. So in this case, you start off generally with a lump sum, put it in the bank. They will give you interest, but you'll be taking away payments. So as I said, it's a reverse of a reducing balance loan. Now, I think it's better to use this recursion relationship for this case, but we're stuck with this one, and we just need to know that this is a negative to positive. So in this case, it's a negative, as it's a withdrawal by the owner of the annuity. So an annuity is a compound interest investment from which regular repayments are made on a regular basis for a defined period of time. And an ordinary annuity amount will decrease over a period of time, and a perpetuity is perpetual. It will stay the same after each payment. So let's have a look at a question like this. So a perpetuity earns interest at 5% per annum and pays $2,000 a month. Calculate the value of the perpetuity. So what you need to do is think of it a bit like simple interest in this case. So we just need to identify some different variables. So we've got a 5%. So this looks like an interest rate to me. So we can put in 5% per annum. And what else can we see? A month. So we're just doing one period, and we are earning $2,000 interest a month. So the question's asking you, what is the principal, if we know the simple interest formula in this case. So let's recall that I equals the interest equals the principal times the interest rate times the number of compounding periods. So we're just going to substitute into there. So we know that 2,000 is the same as the principal multiplied by the interest rate. Now, if we have a look at the interest rate, it's 5%, so it's 0.05. Now it says per annum, we have to convert that down to per month. So it's 5% per month, and then one compounding period. Now we can rearrange this. So we just say, well, therefore the principal is equal to $2,000 divided by, or all over the interest term. And because it's time one, we can ignore that. So we just get out our calculator and give that a crack, and that should get you to $480,000. So let's have a look at now calculating the value of an annuity after a certain number of periods. So we've got Claire here, and she's going to buy an annuity for $200,000, and it's going to pay her $20,000 every year. Now, interest is earned at 4% per annum, and we want to determine the balance after 3 years. So let's use our recursive relationship here. And so we've got the value after n plus 1 years equals the growth rate multiplied by, in this case, we'll start off with the principal plus the negative withdrawal. So we can really think of that as a negative in this case. So that's why I say you can just think of this actually as a bit like a reducing balance loan, because of this negative repayment. You're going to be taking out this $20,000 each year. So let's get and have a look at this. So we've got, we'll go. The principal, that's what here, $200,000. And let's write in our relationship, AN plus 1 equals our growth rate. Now what's our growth rate? Well, it's 4% per annum. And well, that's the interest, isn't it? So I equals 0.04 per annum, but that makes our growth rate 1 plus 0.04, so it's 1.04. And we're going to multiply that by, in this case, our principal, which is $200,000. And that's good. Now we just need to withdraw that $20,000. So we'll put that in brackets so our calculator doesn't get confused. And take 20,000. And that should equal, can I get my calculator out nice and handily? And we'll do this over here. Okay, 1.04 multiplied by 200,000 equals 208, and now we just need to take out the payment, so it's 188,000. 100, oops, that's $188,000. Now it's always good to keep that number in your calculator. So well, that's really, if A0 is that, we'll call this A1 here. So that's A1. So let's have a look now what A2 should equal. So A2 is just got to be this growth rate, which is 1.04 multiplied by A1, which is 188,000. It's easy enough to keep that in brackets. Then we'll take away the 20,000, and that's going to, so I just need to find my calculator. There we are. So when I talk about leaving that number in your calculator, all I'm going to do is multiply this by 1.04. So I know what that number equals now. Then I'm just going to take away the 20,000. So that's 175,520. And then after 3 years, so let's work out A3. So 1.04 times 175,520. Take 20,000. And grab that calculator again. So times 1.04. You can see I'm keeping the previous answer in all the time just to avoid rounding errors. And then we just need to take away that 20,000. And that should be 162,540. $162,540. So the balance after 3 years is $162,540. So you can see that if the periodic payment, this $20,000 here, is greater than the interest or how much it grows, well, that annuity is going to run down to zero eventually, isn't it? But if the interest and the periodic payment are the same, then it's perpetual. It's a perpetuity. Okay, finally, are you able to, what's this? Use the recurrence relation to model that annuity and on the effect of the amount invested at the moment to find the future value. When you're good with that, please work on exercise 6.4.